All right, we're back. This is page 3 of Calc AB Notes 3. We're talking about connecting motion to derivatives, right? So you have position, the derivative of that is velocity, the derivative of velocity is acceleration. So we want to answer some questions and kind of really make concrete some of the things we talked about in the previous video. So there's actually several things we want to do in this problem. So we're going to describe the particle's motion, try to create a graph like we did on page 1. We're going to find displacement, which is relatively easy to find. You could actually do that as the very first step if you wanted to, and then find total distance traveled, which is way more work. So let's get started. So I'm going to definitely need to know the velocity and the acceleration. So I'm just going to go ahead and find that. So connect velocity to position, right? How do you do that? You say that s prime of t is equal to v of t. Actually, I think I should probably say that v of t equals s prime of t. So just like, I always worry about the readability of my work. So I think this is way more, why am I putting an I there? I think that this makes more sense. So here, 6t squared, 42t plus 60. So I'm gonna have to factor this and find the zeros, but it's easier to find the acceleration directly from this form. So I'm gonna say that a of t is v prime of t. So you want to make this connection explicit so that the person reading knows that you know what you're doing. So do it, right? Once you get that out of the way, we need to know when v of t equals 0. So I'm going to factor this 6 t squared minus 7t plus 10, which factors even more, thankfully, because otherwise nobody wants to be using the quadratic formula. T minus 2 and t minus 5. So if v of t equals 0, then I know that either t is 2 or t is 5. So those are the places that this particle that's moving could change from moving to the left to moving to the right or back again or whatever. Or maybe it just pauses for a second. That's also a possibility. I'm also going to need to know when a of t equals 0, so let's just go ahead and get that. So a of t equals 0 would be t equals 42 over 12, which divided by 6 over 6 is 7/2. Okay, so we got a lot of stuff here. You'll also notice a cubic, the 0 of, what am I trying to say here? All right, so when you have a cubic function, also I really have to sneeze, so that's going to kill me throughout this video. I kind of hope it just happens. I don't know. So bad. Woo. Okay. So the zeros of the derivative of a cubic, if you average those, you will get the 0 of the derivative of the derivative. So what I mean there, this is also, this is just an interesting fact. Like, it's not essential, but here we got t equals 2 and 5, and then here we got 7/2. 7/2 is 2 plus 5 divided by 2. It has to do with the fact that the derivative of a cubic is a quadratic, and then the vertex of a quadratic is at the average of the zeros. So it's not like the most amazing thing, but it's kind of interesting, so I thought I'd point it out. All right, position. So we know that we need to know the position at the starting points and then all the potential turning points, so at the zeros of the velocity. So we're going to make a table here of t and then s of t. Not looking forward to plugging in some of these, but you know, might do synthetic substitution is kind of the way to go on a lot of these. So plugging in 0 though, that's not bad. That's just 3. Plugging in 2, what do I get? I'm gonna do synthetic. So to do synthetic, let me just get this equation on the other computer so I can see it. All right, so I'm gonna plug in 2. So I do 2, and then there's 2 cubed, negative 21 squared, t squared, and then 60 because it's t to the first, and then 3. So it's cube squared first. Okay. So bring down the 2, multiply, bring down, multiply, add down to get 26, I think, multiply to get 52, and add down to get 55. So S of 2 should be 55, unless I made a mistake, which I hope I didn't. So it's 2, 4, 17. 17 times 2 is 34. 60. Yeah, I think that's good. I don't know. All right, I got to plug in 5, so I'm gonna do the same thing. So I'll do 5. Allergy is killing me today, as evidenced by the sneeze, probably. Okay, so let's see. 2, 10, -11, -55, 5, 25, 28. All right, so this should be 28. Synthetic substitution is a way to go on these, by the way. I mean, if you have to do them by hand, which apparently we're doing this by hand, I might go back and do it on the calculator just to make sure everything worked out right. 2, 12, -9, -54, 6, 36, 39. Okay. So I get 39. Now we can kind of check and see if these are a little bit right by doing a sign chart for V of t. So let me do that. So V of t, I'm gonna do a sign chart here. I'm gonna start 0 and 6 are important. And then 2 and 5, 2 and 5. So 0 and 6 are important, by the way, because of this. Like it's arbitrary. You were just told that you had to be between 0 and 6. All right, if I test in the velocity, like, I don't know. First of all, it's a quadratic that opens up, right? So it should just go positive to negative to positive, or test values, test 1, test 4, test, I don't know, 5.5, something like that. And you'll get these, I think. So moving to the right, then moving to the left, then moving to the right. That makes sense, right? Because look at the values. You definitely move to the right, then you move to the left, then you move to the right. So at the very least, possibly right. Okay, so what are we doing here? Describe the particle's motion. All right, so I'm also going to need A of t because I need to know the relationship between the signs. So here's 6, here's 0, here's 7/2. All right, so I mean, I'm testing in, where am I testing? I'm testing in here. I mean, that's definitely going to go negative to positive. So negative to positive. All right, here we go. Let's describe, how much space do I have? I got like some. So I'm going to now answer part 1. So part 1. So for t between 0 and 2, for 0, t, 2, moving right. And then I'm going to say speed is decreasing. And then I'm going to give a reason, right? Moving right, speed decreasing. Because, so you're moving right because v of t is greater than 0. And a of t is less than 0. So I don't think I need that comma there. So v of t being greater than 0 means you're moving to the right. V of t and a of t of having opposite signs means speed is decreasing. So you kind of like explain that in whole region there. So now between, so for, where are we? 2 to 7/2, 2 to 7/2, you are moving left because the velocity is negative. And then your speed is increasing. And then let's say why? Because, so you're moving left because v of t is less than 0. And your speed is increasing because the acceleration is also less than 0. So I should say, well, that looks enough. A of t is less than 0. All right, and we have 2 more regions that we want to describe. So for 7/2 to 5, you are moving left because v of t is negative. God, it's like I forgot how to write. But your speed is decreasing. And then we can say why. Because, so moving left because v of t is less than 0, and a of t is greater than 0. That's why your speed is decreasing. So opposite signs on velocity and acceleration, speed decreasing. Do I have enough space? Maybe. And then finally, for 5 to 6, you are moving right. It's really obnoxious to have to do this for the entire trip. Usually it's just like between 5 and 6, like describe what's going on. Moving right, speed increasing because v of t is greater than 0, and A of t is also greater than 0. All right, I think that that describes the entire thing. So I'm gonna do like a weird highlighting job here. I'm gonna highlight like the regions where speed is increasing, I guess. So speed is increasing here, speed is increasing here, and then speed is decreasing here, and speed is decreasing here. And you can tell because velocity and acceleration have opposite signs. All right, what is it? So that was like part 1 of like 4, so this is good. All right, so I mean, we're basically done with part 2 though. Create a graph of the particle's motion. So we just need our table. So 2, I need to go from 3 to 55, so that's crazy. So what's important here? I need 3, I need 28, this is not going to be accurate. I need 39, I need 55. So why write 54 then? 55. All right, we got that. So, man, you just take off between 0 and 2. So here, I might need to move this down, actually. I did not realize that we were going for such a wild ride between 0 and t equals 2. All right, t equals 0, we're here. And then t equals 2, we're here. And then you just kind of like keep moving up a little bit as you go. So t equals 5, we're going to be at 28. T equals 5, and then t equals 6 will be at 39. T equals 6. Okay, here it goes. We went like this, to this, to this. So the actual motion, though, just kind of looks like here to here, to here, to here. Like it's just going back and forth. But we can't really draw it that way. So that looks good to me. And also it like makes sense, I think, with our graph and our description. I think the description kind of is encapsulating what's happening in the graph. All right, find the particle's displacement. All right, displacement is the easiest thing to find because the displacement from 0 to 6, so I'm going to say displacement is really just going to be the position at 6 minus the position at 0. So that's just going to be 39 minus 3, 36 units, I guess, because we don't really have units on this problem. So that would be my answer there. And then finally, the total distance traveled. All right, so total distance traveled is the most annoying. So what we need to do, so you basically find the absolute value of the displacement on each time interval. So I'm going to say my work for this could look like, so from 0 to 2, you're going one direction, right? So the absolute value of s of 2 minus s of 0. Then from 2 to 5, I'm going to say it's the absolute value of s of 5 minus s of 2. And then from 5 to 6, it's the absolute value of s of 6 minus s of 5. All right, and now we need to find these values. So you can basically find them in the table. So like here, this would be 52 units that you moved. And then this would be 27 units. I mean, so it's negative 27, but we're going to do absolute value. So your displacement is negative 27. The distance traveled is positive 27. And then here, the displacement and the distance are going to be the same. They're going to be 11. So this will be 52 plus 27 plus 11. So what is that? 38, I don't know, 60, 90 maybe? All right, I feel like I should check this on the calculator. So I'm pretty sure everything is right. The only thing that might be wrong is the actual values that I found, because I went through them kind of quickly. So let's see. I'm going to define s of t, and it's going to be 2t cubed minus 21t squared plus 60t plus 3. All right, so what could I do? S of 0, S of 2, S of 5, S of 6. All right, those were all right. So then for displacement, I just needed to do S of 6 minus S of 0, which is what we got. And then for distance traveled, I need to do the absolute value, S of 2 minus s of 0 plus the absolute value of s of 5 minus s of 2 plus the absolute value of s of 6 minus s of 5, which is 90, which is what we got. Woo! We could also find the derivative of s of t if we need to with respect to t. We can solve when that equals 0 for t. We get 2 and 5. So it looks like everything is right. So I'm going to go back to the notes, show that to you one more time, and then I will come back in the next video and do the next problem, which is going to be really similar. So here's all the work that we did. It's a ton of work. I mean, there's no part of this that's not a lot of work, but you get good at it, and it helps you to understand the concept. So I'll be back in the next video to do a little more. So see you there.